Okay, we're going to do topic number 24 now. And you can obviously see that there's a radical on topic number 24. The way to get rid of this is pretty simple. We're just going to square both sides. So if I square the left-hand side, that becomes 16. If I square the right-hand side, that basically is going to get rid of our radical. So we'll just be left with 6 minus 2y. And then after that, it's just solving a two-step equation. So I'll subtract 6 from both sides. I'll get 10 equals negative 2y. That must mean y equals negative 5. And that's it. We should plug it back in just to make sure that it works. But honestly, I think we'll get 6 plus 10, which is 16. And the square root of 16 is 4. So we're good to go. Topic number 25. Now we've got two radicals. They're on the same side of the equal sign. So I think the easiest thing to do here, since we have a subtraction in the middle, I think it would be easiest to add it over to the other side. If I add all of this stuff over to the other side, we'll have the square root of 3u minus 5 equals a positive now, 5u minus 15. I can square both sides. That's going to get rid of both of those radicals. So we'll be left with 3u minus 5 equals 5u minus 15. And then we're just solving a couple step equation here. We should get 2u if I subtract 3u from both sides and a positive 10. And so u must equal 5. And you can plug that in to make sure that that works. But I think that's the final answer. Topic number 26. Same situation here. I'm actually going to move this stuff over to the other side by adding a negative, or adding the square root of u to both sides. But this one's going to be a little bit more work. I might actually have to zoom in a little bit because I'm going to have to show quite a bit of work on this one. So once I add it over, I'll have the square root of u minus 21 equals 3 plus the square root of u. Okay, now I can square both sides, but this is going to get a little tricky. So if I square both sides, this left-hand side is pretty easy. It's just u minus 21 because the square root is gone. But over on the right-hand side, I'm actually going to have to FOIL that now because we have two terms that we're squaring. And so if you think of FOILing, that's like if I were to multiply this again by 3 plus the square root of u. So my first terms would be a 9. My inside term and my outside term together. So my inside term looks like it's 3 root u. Outside term is also 3 root u. That means we'll have plus 6 square root of u. And then my last terms are square root of u squared, which is just a u. Okay, so now I'm going to move everything to the left-hand side other than the square root. I really want the square root by itself so that I can square both sides and just be done with the question. So if I move everything over to the left-hand side, I'm going to subtract 9. I'm going to subtract u at the same time. So therefore, if I subtract u, that's a good thing. That means these u's are going to cancel out, honestly. Minus u and minus 9. We'll have minus 30 equals 6 root u. Divide by 6, divide by 6. We get negative 5 equals the square root of u. Now I can square both sides. Make sure we're going to square that negative as well. So just like that. And so therefore, we should be left with 25 equals u. And we're done with that problem. And you can plug that in to make sure that that really works. But I think I can do it right now in my head. It looks like it does. So let's move on to topic 27. Topic number 27. I'm going to start by squaring both sides once again. If I square both sides here, I'll get 6w minus 8 equals w squared. This looks to me like we're going to have a quadratic if I move everything to one side. I'm going to move everything to the right-hand side because we've got a positive w squared over there. I don't want a negative a value. So this means if I moved everything from the left, I don't have anything left. W squared is still over there. I'm going to subtract 6w from both sides and add 8 to both sides. So that's my quadratic. Now I can factor this quadratic. and I will get w minus 4 and w minus 2. So my two answers would be a positive 4, because these are supposed to equal 0. So a positive 4 would make that first parenthesis equal 0. A positive 2 would make the second parenthesis equal 0. And then I should plug both of these back in just to make sure that they both work, because there's a potential that you will get some where they won't work when they plug it back in. When we do a bunch of squaring square roots and stuff, things can get a little funky sometimes, and we might not actually get an answer that works. But 6 times 4 is 24. If we subtract 8 from that, that's 16. The square root of 16 is 4, so the 4 works. If I plug in 2, 2 times 6 is 12, minus 8 is 4. If I square root 4, that equals 2, so 2 also works. On to topic number 28. Now we're getting a little bit more extreme on this problem. We're going to square both sides right off the bat. So square it, we get y minus 1 squared, which is really, maybe I'll write it out first, which is really the same thing as y minus 1 times y minus 1, right? That's squaring it. So we're going to have to FOIL. So we get y squared minus 2y if I FOIL the outside and the inside. And then my last term would be a positive 1 equals 8y minus 20. I'm going to move everything to one side, and I'll have a quadratic if I do that. So I'll subtract 8y and add 20 to both sides. So I get y squared minus 10y plus 21. So it looks like 7 and 3 would be some good numbers here. So y minus 7 and y minus 3 are my two solutions. Remember, this equals 0. I didn't put that over here, but when we moved everything to one side, that's what that equals. So we'll have 7 and 3 as our factors and our solutions. And then I got to plug those back in. I'm not going to do that. I'm not going to waste your time. I think you guys can manage that on your own. But you should plug those back in just to make sure that they work. And we'll move on to topic 29. For topic 29, I'm going to move all of this right-hand side of this radical over to the right-hand side of the equation. So square root of 3x plus 18 on the left-hand side equals 1 plus the square root of x plus 7, because I moved it over. We're going to square both of these. So if I square this, that's pretty easy, but if I square this, we're going to have to FOIL again. So let me actually write it out. There's a lot going on this problem, so just try to hang on. The left-hand side is pretty simple. That's just 3x plus 18 because we squared a square root. That's going to be equal to 1 for our first terms. Our outside and our inside terms together would be 1 times x plus 7 and 1 times x plus 7. So we'll actually have 2 square root of x plus 7s.
Just a quick update. Any students who are planning to serve detention today, detention has moved to room A103, Ms. Bergen-Gabor's room for today. If you're planning to serve, please go to A103 today.
Sorry about that. Hopefully you are not serving detention today as you listen to this. But we're going to square our last terms now. And so if I square those last terms, that's the square root of x plus 7 times the square root of x plus 7, which is just x plus 7, because you're squaring a square root. I'm going to move everything to the left-hand side now. So except for the radical. Like I said, I want to keep the radical on one side just by itself if at all possible. So we're going to subtract 1, we're going to subtract 7, we're going to subtract x, all in our first step here. That means we'll have 2x left over. And if I subtract 8 total, that would be plus 10 equals 2 radical x plus 7. I'm going to divide both sides by 2. So we should get x plus 5 equals the square root of x plus 7. Now I've got to square both sides again. So all of this stuff is going to get squared. All of this stuff is going to get squared, which is a binomial. So we're going to have to FOIL this again. There's a lot of foiling going on in this problem. So that would mean we have x squared plus 10x plus 25 equals x plus 7. because we squared a square root. I'm going to move everything to one side one last time, and then we're going to factor. So we'll have x squared plus 9x plus 18 equals 0. I'm going to factor this, and we should get, let's see, 6 and 3 look good, meaning my two solutions are -6 and -3. Now, there's a good chance that one of these won't work. I'm not going to go through it. I'm going to let you guys check it because all you have to do is plug it into your calculators. But there's a good chance that one of those might not work on this topic. So I'd plug them both in just to check. We have one more topic to complete. Oh no, we got a couple more actually. Sorry. A couple more topics to complete here, but now we're going to talk about using I. So for topic number 30, I'm going to write this in terms of I. You cannot do a single thing on this topic until you get rid of that I value from inside here. If you don't know what I equals the square root of -1. So I'm going to separate out a -1 before I even start this question from this negative radical. If you start doing some of the other rules that you know about radicals before you take out a -1, you're going to get the wrong answer because you can't do the rules if it's not a real number. So this is not a real number, so we're going to do that first. If I take out a -1, that'll leave me with the square root of 63. And now I can break down that 63. So this is just an I. That'll be a part of our solution. But I can break down the 63 into the square root of 9 and the square root of 7. The square root of 9 is 3, so I times 3 times the square root of 7. Oops, I don't know why I wrote a 3 there. Times the square root of 7 is the final answer. But if we wanted to be professional about it and write it correctly, I'm going to put the I after the 3, like that. 3I times the square of 3. Topic number 31. Simplify the expressions below as much as possible. Leave no negative numbers under radicals and no radicals in the denominators. This is the same thing we just got done doing, except we've got an operation to take care of now. So I'm going to pull out my calculator just because I'm going to probably need it here. But I'm going to rewrite this first one as the square root of 121, which is really 11, times I times the square root of 144 because I took out the square root of -1. Now I can do those operations again. It looks like I'll have 11 times 12, which is 132, I think. Yep, 132. So that I will just be a part of your answer. This is an 11. This is a 12. And so I times this times 132. I'm going to put 132I as my final answer. Moving on to the next one. If I pull out an I right away, I'll have the square root of 12 and the square root of 4 on the bottom. And you could do the square root of 4. I'm not going to do that. I'm actually going to do my operation that I know about dividing square roots, where I can divide square roots if they're both under a radical. The square root of 12 divided by the square root of 4 is the square root of 3. And that would be my final answer for this one. You can actually just divide square roots. If you would have changed this 4 to a 2, you would have had to simplify this 12 into 4 and the square root of 3. Or I guess the square root of 4 and the square root of 3. Well, the square root of 4 is 2. You would have ended up canceling out the 2's and been left with the square root of 3 anyway. So it's just more work to do it that way. If you know those shortcuts, if you know those properties, you can just divide those two radicals right away. That's really going to save you some time. Topic number 32. I see that we're subtracting these. This shouldn't be that hard. What I'm going to do is I'm going to change this to a plus. I'm going to distribute my negative, so that becomes a plus, and that becomes a negative. And now the parentheses are basically unnecessary. We've got 3 and 2, that makes 5. We've got -4i and -5i, that's -9i, and we're done with this problem. We've got a chance to FOIL now on topic number 33. We're going to FOIL the first term, so 2. Our outside term would be -2i. My inside term would be -3i. And my last term would be, really, it's going to be a a positive 3I squared, which we're going to have to talk about now. I squared is really the square root of negative 1 times the square root of negative 1, which is really the square root of negative 1 squared, which would cancel the square root and the squared. We'd just be left with negative 1 as our final answer. So I squared is really just negative 1. If I apply that to this problem, really what we're doing here is we're multiplying 3. This 3 is going to get multiplied by negative 1, which makes it a negative 3. And then my inside terms I can combine to make a negative 5i. I'm working backwards here. And then I'm going to bring down that 2 next. So, and then I can combine those solo numbers by themselves. I'll get a negative 1 and then minus 5i. And that's really all I need to do for that problem. Next one, it says write your answer as a complex number in standard form. It says divide on this problem. I don't really like that it says divide because really what we're doing is we're rationalizing our denominator. We're not allowed to keep an I on the bottom of a fraction because that's a radical, and we're not allowed to leave answers with radicals on the bottom of our fractions. So here's what we're going to do to get rid of it. We're going to multiply it by what's called the conjugate, and that is this. I basically took this and I just changed the number or the sign that's attached to the I, because what's going to happen is when I do my inside and outside terms, those are going to cancel out. So I'm going to FOIL this. Well, on the top, I guess I'm just going to distribute. If I distribute this, I'll get negative 4 plus 12i. And on the bottom, when I FOIL, it's going to be a positive 1 for my first term. My inside terms and outside terms should cancel out. This would be a positive 3i. This would be a negative 3i, and they're gone. So then the last step would just be to do my last terms, which would be a negative 3i and a positive 3i. So think about this for a second. This goes back to our last topic. If you haven't watched the last one, you need to watch that again. But negative 3i plus 3i is really going to be a positive 9. Why is that? Well, negative 3 plus positive 3 is a negative 3, but you're also multiplying that by a negative 1 because I squared is negative 1. So negative 3 times negative 1, negative 9 times negative 1 is positive 9. And so then we'll be left with negative 4 plus 12i over 10. And it seems like you can't really simplify too much, but I do see those numbers are all divisible by 2, so we could simplify this to negative 2 plus 6i over 5. If you cut all those numbers in half, that would be simplified form for number 34. Okay, topic number 35. So for topic number 35, it's nice to have a little template. I would definitely write this down, what I'm about to write down in your notes. We know that I equals the square root of negative 1, but in this case, I'm just going to write it as I. I squared is the same thing as the square root of negative 1 squared, which is, as we talked about in our last two topics, negative 1. I to the third power is basically these two combined because one of them's I squared and one of them's I, so we would really have the negative square root of negative 1, which is the same thing as saying negative I. Okay, so we've talked about this one, and this one as possible answers for this question. What else could we do? Well, what if we had I to the fourth? I to the fourth is really just 2 of these, 2I to the seconds, which means we would have a negative 1 times negative 1, which is a positive 1. And I know I'm going fast through this. If you have any other questions, you should ask me in class, but those are basically going to be your 4 answer options for this question. Because if we go back to I to the fifth, I to the fifth is really I to the fourth and I, which is 1 times I, which is just I. If we do I to the sixth power, We get -1 again because it's really I to the fourth and I to the second to make I to the sixth. So we're back to -1 now. And you can see the pattern starting. I to the seventh power would be I to the fourth and I to the third, which would be a negative I times 1, which is just a negative I. And I to the eighth, I'm running out of room, is just I to the fourth and I to the fourth, which is 1 times 1, which is just a 1. So here are your answer options, and you can see that we've made a pattern. Now it says 33 is our number. So here's what I like to do. I like to pick a number that's divisible by 4 because, for example, um, I to the fourth would be 1. I to the eighth would be 1. You can imagine I to the 12th would be 1. I to the 16th would be 1. So we can figure out where we're located just based on numbers that are divisible by 4. Let's take, for example, 32, which I know is divisible by 4. So if we had I to the 32nd power, that's divisible by 4. That's going to equal 1 because it's a power that's divisible by 4, like I have my arrows on the left-hand side. I to the 33 is just 1 more than that. So you should know your pattern is going to be the next one down, which would be I. So I to the 33 equals I because that's where it falls in my pattern. So for all of these, find a number that is divisible by 4 and then use your pattern to figure out what's going to be next.